Hello everybody, my name is Ethan. Welcome back to the channel where today we are going to be continuing our learning in C#. In the previous episode, we finished our classes and objects section of the course. In fact, we only have 3 more courses left, or 3 more chapters, I should say, left in the Learn C# kind of textbook, if you want to call it that. I don't know if you'd want to call it that, but it's basically the little scheduled learning. And today we're going to talk about interfaces. So without further ado, let's just jump right in. Introduction to interfaces. Since programming is complex, it's easy to make mistakes. For example, maybe we try to use an int like a string. This would cause a type error. C# has rules built in that check for those mistakes before we use that code in the real world. The diagram below shows the estimates. The diagram below estimates the number of bugs in our code at each stage of development. We discover and fix some of those bugs at each stage, and so the number decreases from left to right. Sadly, we can't fix every bug, but if we catch bugs earlier, then we save ourselves work and users frustration. So when we say that C# is a type safe, it's because it helps us catch bugs at one of the earliest stages, the type checking phase. So we have this nice little graph here that talks about bug reduction techniques, planning, type checking, running code, peer review, user feedback. The difference between an int and a string is clear, but what about custom defined classes? Say we made a fruit and vegetable. Can we use plant seed on both? Do they both have a seed property? The computer running the program needs more information. In this lesson, we'll dive into interfaces, which are a set of actions and values that describe how a class can be used. This lets the computer check that we are using each type legally, thus preventing a whole new type of errors. In this lesson, we'll learn how to build our own interface and write classes that implement an interface. Based on the code in program.cs, we can expect the sedan class to have a speed property, license plate property, wheels property, and a honk method. So when we look here, you have that method honk, another method called speed up and slow down, as well as some interesting things like a property, license plate, speed, wheels, and then of course the self property there. Sorry for the quick cut over to a completely different day in a completely different time. I am just had to quickly deal with a little bit of a family thing, and so I am back now to continue our learning. I'm going to just pick up right where the other Ethan left off, and that is with built-in interface. For this lesson, we'll be designing a new set of transportation machines that satisfy the requirements of both car designers and the highway patrol. We kind of talked about this to start, but we'll start with the instructions. Just like classes, interfaces are best organized in their own files. In iautomobiles.cs, within the Learn Interfaces namespace, create an empty iAutomobile interface. So we're going to create an interface by using the keyword interface, and we'll create it by saying it is called learn in it wants us to create within the learn interfaces name, create an empty one called iAutomobile, and inside it wanted us just creating an empty one to start. Add these properties and one method to the interface. So to start, we will create a string called license plate, a double called speed, an int called wheels, and a void method called honk. So we have a couple of options up here, obviously. So let's first create a string property. So, properties. In the property section, we'll create a string license plate. To start, we'll just do get. The properties only need a getter. Use get shorthand demonstrated in the narrative for ID. So we're using the same one here, where we just specified that it has a getter, but not a setter. Finally, and then finally a void method named honk. So if we just say void honk, we can open up that method then, and I don't know exactly what it wants us to do for that honk method. But let's take a peek just to make sure. Okay, so it's just that, I believe. Okay, looks like we did that all correctly, so that is nice. Implementing an interface. Our interface is complete. Pretty easy, right? As we design our automobile-like classes, we'll need to implement this iAutomobile interface. In C#, we must first clearly announce that a class implements the interface using the : syntax. So we'll do class sedan using the automobile interface. This empty sedan class promises to implement the iAutomobile interface. In other words, it must have properties and methods the highway patrol asks for: speed, license plate, wheels, and honk. If we do not, we get a type error like sedan does not implement interface member iAutomobile.license plate. To fix this, we'll need to define the members in the interface. Simple enough. In sedan.cs, let's create an empty sedan class that implements iAutomobile interface. Use the : notation. So we will do class sedan, the : and then iAutomobile, and then we'll open that up. First, we're starting off with just a very simple empty one, but obviously, look, we have a bunch of errors. You should see the error CS0535 telling you that a sedan needs to implement the interface. Implement the interface by adding the 3 properties and 1 method defined in iAutomobile, which you can check in iAutomobile.cs. So we should implement them by first denoting that they are public methods or public properties, and we'll start with the string with license plate. Actually, I don't like opening it up like that. I'm just so used to it at this point. Then we'll have another one called public double, and I believe it was speed. Yes, it is speed. And then we'll open that up with another get statement, and then finally, or not finally, public int. We will want to do, I believe it was wheels. Yep, wheels. Get. And then we'll do the last one, which is public void honk. Let's see if we did it correct here. So within honk, call console.writeLine to make the sedan honk. Okay, so that is fine. We'll then add a console.writeLine and add the word honk. And perfect. What interfaces cannot do? The sedan needs to satisfy more than the highway patrol's rules, the iAutomobile interface. The car designers have asked that sedans are built and move in certain ways. It must have constructors and methods that aren't required by automobile interface. This is okay in C#. The interface says that what a class must have. It does not say what a class must not have. In fact, interfaces cannot specify 2 types of members that are commonly found in classes: constructors and fields. Add a constructor to the sedan class with 1 parameter: speed of type double. It should set the speed property to speed and set a random license plate value, and set wheels to 4. To make a random license plate, a utility class is provided for you. Use the constructor like so. Tools.generate license plate. So it wants us to create a new constructor. So to do that, we will, in parameter speed of type double, it should set the constructor. So if we do sedan, and there is a word that goes before, but I'm not remembering it. And we can open it up we will set speed equal to speed. Double speed is equal to speed. String license plate is equal to tools dot generate license plate, and then wheels, so we'll do int wheels equal to 4. And there's something I do here, but I'm not remembering it. It's just public. I think this is what we would want to do. Though I could have definitely made a couple mistakes here, and that is obviously a-okay. Yep, the constructor should set license property to a random value. Okay. So instead of license pull, not explain code, please. Instead, we just want string license property. Let's try and run it again. Random value. Looks like that's what I'm doing. Let's take a peek at the solution and see what is happening under the hood here. What was it asking us to do? I felt like we created, okay, public double speed in sedan now. Okay, public sedan double speed. So we have. Oh, it should go at the end. That's why it's probably messing up here. Speed is equal to speed. License plate is equal to tools.generate license plate. Okay, so let's keep my code here. I actually do have it all the way at the end here. So instead, though, we're going to get rid of our variables that we have created here, and again do license. Hopefully that works. And that did. Let's add a void speedup method that increases speed property by 5. So we'll add a method called void speedup, and in speedup, speed plus equals 5. Public. Gotta remember to put public so we know how to access the method and who can access the method, right? Did you get an error? There is no setter for the speed property. Add a private setter such as private set to the speed property. So it says public is not a modifier, right? So let's go to speed and do a private set. So let's take a peek under the hood here and see what exactly I'm doing wrong. It literally looks like the only difference between my code and their code is the fact that there's a space after this, which I don't know if that would significantly change it. So yeah, it doesn't change it. So why is it not changing it? Here's an example of a property with getSet method. Without a setter, the speedup method won't be able to access speed, and you'll get an error like public is not a valid item. Let's check and see if they have it as a private. Speed up is public. No. Looks like our stuff is just in different spots, perchance, but I'm not exactly sure why I'm getting an error message here. At this point, I'm just going to have to replace with solution, unfortunately, and then look at step 4. Add a void slowdown method that decreases. So we have now void slowdown, which is minus equals, yeah, pretty self-explanatory. It's because I added a void speed up method to this. Okay. Implementing an interface again. We've completed a sedan class that classifies both car designers and highway patrol. It can be constructed and change speed, and it implements the iAutomobile interface. But sedans aren't the only automobile on the road. There could be multiple classes that implement an interface. For example, we can create a truck class that also implements the interface. This is where we start to see the power of interfaces. Even though sedan and truck are different types, we can assume that they both behave similarly because they share an interface. Car designers can build different car values, vehicle classes. I don't know where I got car values, but vehicle classes, but the highway patrol can treat them all the same. In truck.cs, create an empty truck class that implements the iAutomobile features. So we'll create a new one where it takes from iAutomobile, and we'll open that up, run the code, of course. You should see an error telling you that the truck needs to implement the interface. Implement the interface by adding the 3 properties, one method defined in iAutomobile. So again, we'll do the same kind of things that we did in the first one. So we'll do string license plate. And I believe we do a getter. Then we'll do double speed with a getter, and then a int wheels with a getter, and then finally we'll define that method by doing public void. And I believe I do I do public on all of these? I think I do, but I'm gonna wait for right now. Honk. Or open that up and do the console.write line. Honk. Yeah, sorry, I messed up there. We do obviously have to put public. I said it, but then didn't do it. In a little bit of an interesting spot right now with my head, so let's just do that, and hopefully that works. Perfect. Let's finish the truck class. The car designers have asked that trucks are built a little bit differently than sedans. Trucks need a property called weight. Whenever a truck is constructed, its number of wheels would depend on its weight. For example, a heavier truck might need 12 wheels instead of 18 wheels to support itself. Just like sedans, trucks will also have speed up and slow down. Add a public double weight property with just a getter. So I'm going to do that. I'll put it right below the other properties that I have set up. And it wants it as a double this time, so we'll add a weight and add just a getter. So hopefully I did that correct. Perfect. Let's, it takes 2 arguments, does not contain a constructor that contains 2 arguments. Okay, let's add a constructor to the truck argument that takes 2 parameters, double speed and double weight. It should set speed property using speed and set the weight property using weight. Set a random license plate value using the tools.generate license plate, and set wheels to 8 if weight is less than 400, and set wheels to 12 otherwise. So we'll do that by going down below here and doing public, not class, just public, and then truck. and it should take a couple of arguments. The first one is a double called speed, and the second, let's get our keywords right here, double called speed, and then a double called weight. Then let's open it up, and as it said, it wants its speed to equal speed, and its weight property to equal weight. Finally, it wants the license plate to equal the random value, which is tools.generate license plate. And then it wants to set wheels. We're going to actually use an if-then statement. So we're going to say if weight is less than 400, we will wheels will be equal to 8, and we'll do a nice little else statement. Else we'll say wheels equals 12. Hopefully did that right. Taking a little bit of time this day, but oh, it's all good. Perfect. So let's add a void speedup method that increases speed. So again, I'm going to go down below here. I'm actually going to put it below honk. So we'll do a public void. We'll say speed up. And this method will increase speed plus equals 5. And we didn't do this, so we want to put a private set to the speed. And finally, I think that one should be good now. We'll add a second public void slow down that will take speed minus equals 5. And that should be the truck class done. Perfect. Testing interfaces. Now we have a sedan class and a truck class that implement the iAutomobile interface. Though they have some different behaviors, they both have the properties and method defined in the interface. Double speed, string license plate, int wheels, void honk. At this point, we can be confident that we won't cause any errors if we try to access the members in either sedan or truck class. Create 2 sedans and a truck. So we'll do that by just saying, have caps lock on. Sedan, and we'll call it sedan1 is equal to new sedan with a speed of 60. Then we'll do another sedan called sedan2 is equal to new sedan with speed of 70. Oops. And then we'll do finally a truck called truck1, which is a new truck that has a speed of 45 and a weight of 500. Three console.write lines, so we'll do that really quick. Sedan1 dot speed, sedan1 dot wheels, sedan1 dot license plate, and I should have a space there. And I am going to do this and change this to a 2, and then this to truck1, and I might be getting the syntax wrong here by putting commas. Hopefully it's not that bad. Yep. Okay. What does it want me to do? Okay, it wants me to do that instead, which is amazing. Okay, so I'm going to get rid of these two for right now. And I will do something with string interpolation instead here. So, Sedan 1 has a speed of Sedan 1 dot speed and a wheels of Sedan 1 dot wheels and a license plate of, and then finally we'll do Sedan 1 dot license plate. And now with string interpolation here, we can add a couple of console write lines. So then we'll say Sedan 1, 2, 2, 2, 2, and then finally up here we'll do truck, and we'll replace the value of Sedan 1 with truck, and there should actually, it should be truck 1, and was my bad there. Truck 1, and see how this works instead. Sedan 1 has a speed of 60 and a wheels of 4 and a license plate of. Perfect. Call speed up on all three mobiles. So we'll do Sedan 1 dot speed up, Sedan 2 dot speed speed up, truck 1 dot speed up. Let's run that. Finally, using console.WriteLine, print out all the three automobiles' new speed. So we'll do a console.WriteLine, and we'll do another little bit of string interpolation here. Sedan 1's new speed is Sedan 1 dot speed, and in this case we will just copy and paste this once more, saying now Sedan 2, in this case though we want truck 1, and instead of Sedan 1 we'll do truck 1's. And they all sped up a little bit there. Perfect. Last one is the review. Well done. In this lesson you've learned interfaces that are useful to guarantee certain functionality across multiple classes, built an interface using the interface keyword, defined properties and methods, but not constructors or fields in the interface, built classes that implement the interface, and added members to the class that weren't specified in the interface. All right, cool. Let's check what's up next. It appears we have a new little section called Inheritance Next. So we'll do that in the next video. Thank you so much for watching. If you enjoyed, please be sure to leave a like, subscribe, and we'll see you in the next one. Peace out.